Alright, good morning ladies and gentlemen. Welcome to this last construction course. And this course is actually going to be on computerization and clinical information systems. I have no financial interest in this particular presentation. Today we're going to be talking about clinical information systems. We're going to do an overview of the clinical information systems. We're going to do functionality bundles. We're going to do need and cost benefit analysis. We're going to do a smallish talk on how to design the databases, how to model your data, and on descriptive statistics. Descriptive statistics means how do you present your data. So that is the basic overview of our course. We'll also be talking about levels of evidence, different types of studies, and which tests to use. The basic idea behind this course is it's basically a nuts and bolts course where we're going to be talking of how to do the thing. We're not really going into the depth of the theory of. Good morning, sir.
Good morning. सिर्फ एक सुनने वाले.
So we still have to do our job. At this moment, I welcome Dr. Naik. Dr. Naik needs no introduction. He is the doyen of Indian research methodology. He is running one of the most successful workshops on research methodology in this country. To just sum up what we've started, I've actually started off with a basic overview of this particular course. We'll be talking about clinical information systems, the database, data modeling, and how to do descriptive analysis. So we'll be talking about levels of evidence, different types of studies, which tests to use, ethics in research. The basic idea is it's a nuts and bolts course. I have no financial interests, and well, I believe that my audience would consist of people in standalone practices, people in group practices, people in institutions. Unfortunately,
so she represents everything.
Yeah, she represents everything. So
you are from where?
So basically, you have to do a need assessment. You see, it's just like having mobiles. They're all across. You get a mobile for 800 rupees, you get a mobile for 40,000 rupees. They're doing basically the same thing. So those in institutional practices probably can afford more. Their information needs are slightly different. So the basic idea is you should be able to define your needs before you actually go in for computerization. You'll always have to mix and match technology, and remember that your information needs will keep on changing as time passes. The different names given to the information systems: transaction processing and management information systems. These are the ones which are most commonly being provided to us in the name of EHRs and hospital records. So far as selection of systems, when you want to do computerization is concerned, always remember you want it to be scalable. You should be able to actually increase the number of computers that are working on your system. You should be able to pick up data from this system and put it onto another system, that is portability. And ideal is it should be platform neutral. Whether it is Linux or it is Windows, you should be able to work on one or the other without data loss. Now that does not actually happen in practice. Ram Singh, 46 years, male, having diminution of vision for last 45 days. Now you have 100. This is all data that is coming to you. It is of no use to you till it actually gives you some meaningful input, and that meaningful input is information. So a lot of data would go into a funnel and give you small nuggets of information. So, for example, you analyze age profile, and you realize that most of your patients are say 0 to 12 years of age or 65 to 80 years of age. So So you need to actually go back and do something about it. You need to either increase services, tie up with pediatricians, or provide some extra services. So that is when it becomes information. And when information actually enriches your life, that is wisdom. Information technology is not about computers, it's not about software, it's not about collecting data, processing data, presenting data. It is about controlling technology and getting enriched, getting your life enriched by that. Now, whenever we are going in for computerization, the most important thing is that you see, whatever you're spending is not the final thing. You are going to spend money on maintaining it, annual maintenance contracts, on obsolescence costs, and most importantly, in today's terms, on data security. Now, how does this particular course work? What happens is all your office processes are converted into a master chart. That is what the clinical information system does for you. So you're working on small computers called clients, which are storing information either on the client or on a bigger computer called the server. These systems are connected to each other using wires or wireless means, that's a network. And on this or this, you are storing it in the form of a master chart, which is a database. You can run limited analysis on this database if it is residing on the server, that is online analytical processing. Or you can take this data out, bring it into another computerized environment. You can clean it, extract it, transform it, load it onto a data warehouse, and then you can analyze. You can use massive analysis tools on this data. Normally what is happening here is all people are giving you first 3 components along with this, but nobody is talking of a data warehouse. So in effect, we are losing valuable information of all the clinical practices, of all the experience that is being gained in clinical practices across this country. The basic idea of this course is that we should be able to plug in this and go ahead from that. So I'll just briefly run through the computers, the networks, the warehouse, the database, and then finally focus only on analysis. So what are computers? You see it is this thing which does whatever you ask it to do. So you have some input devices like the keyboard and mouse. It works on the central thing. That box there is a CPU, the central processing unit. This is the main memory or the table on which your computer works. This is the table for the data. The computer's table for the data, the table on which it is working. Then it has some secondary memory, which is its cupboard. Where it goes and stores this information is the secondary memory. Many types of secondary memory. And then once it's done the work, it can show you the thing on the monitor, like it's doing here, or it can give you a printout, or it can plot, and there are n number of devices which are available to you. So I go back to the previous slide, we talked of computers. Now, how do you connect different computers? That's a network. You can connect them by wires, you can connect them by wireless means, you can connect them over a small area, over a large area, different types of methods, optical fibers, wires, wireless, different functional relationships, different topologies, different methods of connecting all these things. And this is how the systems will be talking to each other. This is the language and the protocol that they use. Suffice it to say that this network is connecting these two and is connecting this. Now, what exactly are we doing? From this onto this, we are collecting all that we are doing inside the clinic, inside the office, in a master chart called the database. So database is all this information along with the context in which it is stored. All the ages. Age 46, 47, 48, 49, 32, 86. So all that is stored in a particular format, and what stores it is all these database management systems. Now, apart from storing it, it's supposed to do a lot of other things. So these are the components of those databases. Now, I'll go back to it again. Now, all your information has come into a database which is residing right now on the server. So you can run limited analysis on it. That's online analytical processing. Limited because this is almost like working on a beating heart. You don't want to do a detailed analysis. to slow down your system. So what do you want to do? Now, you want to take this data, which is your operational data on your server, clean it, transform it, and load it into a specialized environment, which is called the data warehouse, where you're storing the detailed information, along with the information about this information, and you make a summary for things that you are going to repeatedly collect and repeatedly access. There are many considerations in a data warehouse which we're not really going to go into. So now I've got 15 or 16 different specialities working together and their relationships between the data that is collected between those 15 specialities. So I end up with something like a snowflake schema. This is related to this, is related to that, is related to that. So I need to have very clear idea about what each block, each segment of my data represents. That is metadata. Now, software is basically the set of instructions that you give it to carry out. Suffice it to say, there are two main types of software that we want to talk of. We want to talk of operating system, that is what controls the machine and its elements. So you have different types: Windows, Linux, Mac, and we have application software, which is your program in which all that you wanted to do is done. For example, you want to do word processing, you do it in Word. You want to have spreadsheets, you do it in Lotus or in Excel. You can do graphics. So you can either have single programs or you can have a software suite, which is like the Microsoft Office. I'm not going into the details of the different systems which are available. So now we've come to the situation where we've got, now we've already discussed, alright, now we've already discussed it up to this place, onto the database. I've been talking about all the clinical applications, all the clinical, everything that we're doing in the clinic being captured into a database. So everything that we do in the clinic, in the office, is a transaction. Theoretically, transaction is anything which is going to cause the data to be stored in a system or to be modified, which is there in that system. There are different places where you use transaction processing systems, like in finance, in human resources, in billing, in marketing, but our main focus is on the clinical transactions. All clinical systems that we use allow some sort of a login methodology wherein we confirm that the person who's logging in is actually the person who's authorized to log in. Once he logs in, he's able to identify the patient who has been registered, and then he can record the history, physical examination, record a diagnosis, maybe order some drugs, record his complaints, order some procedures, and then, of course, he can generate a prescription which can be printed out, or he can order the prescription to be sent from the pharmacy. You have different types, that for the text only. Now, what you can do is you can actually allow, you can draw in these, you can put photographs, embed them, and link them, and once again, you can show your patients how they're doing. So this is the visual presentation of your data. Now I come to the most important aspect of this particular course, that is now what we've done here is we have already made our master chart. We have taken that master chart onto a specialized environment which is our data analysis area, and that is what we call a data warehouse. So here what we can do is there are different types of database management systems and different types of databases. What we are using in ophthalmology most commonly is heterogeneous databases today. And that is actually a challenge because analyzing heterogeneous databases requires specialized tools. How do you store the data that is there in your system? Now, at the time of running the system, you have to be very clear on how you're going to model your data. Today we're using something called the entity relationship data model, which is most commonly being used. Entity, Ramsing is an entity. Age is his attribute. And there is a particular relationship that this attribute will have with Ramsing. You can have only one age. He can be only 47 years old, or 5 years old, or 80 years old. He cannot have, so that's a 1:1 relationship. But Ramsing can have many cars, he can have many complaints, so it's a 1-to-many relationship. He can belong to many families, and many families can belong. He can belong to many families can belong to many persons. So that is how normalization is done. So when you're modeling data, just remember there are two different types of data. One is the categorical data, and the other is scale data. So categorical data simply is qualitative data. It can be nominal, by name. You've divided people by groups. People living in north, in east, in west, in south. Married people, unmarried people. So that is nominal data. Or there can be a particular order to that name. Mild, moderate, severe. Big, bigger, biggest. Right? So there is a particular order to it. We're just talking about this because now we want to define and we want to analyze this data and we want to present it in an intelligible manner to the audience. When you're communicating your data to me, it should make some sense to me. And at the same time, you should be able to get some actionable input out of it. Now, scale data or quantitative data can be continuous, it can be discrete, 1, 2, 3, 4 or 1.24, 1.25, so on and so forth. Now, when you want to do descriptive, so you have two different types of data now. You have categorical data. So categorical data में आप क्या कर सकते हैं? Nominal data में you can tell us what proportion or what percentage of people belong to each category. You know, 50% lived in south, 23% lived in north, 3% lived in east, and so on and so forth. Or you can tell me about mode, which is the most common. You see, most common was people living in the south. So mode is the most fashionable value in normal. When you have ordinal data, when it is in a particular order, now you can do the first two, and you have another possibility. That is the median. Now what you do is, you take all the data, you arrange it in an ascending or a descending order, and you pick up the most central value. That is going to define your data. So that is how you will communicate your data in your research, in deciding your factors. Now, and also in analyzing whether there are any correlations, whether there are any significant differences between your data. When it is quantitative or scale data, what can you do? You can actually add up all the numbers and divide it by the total number that you have. That's the mean. Or you can again arrange them in an ascending order or in a descending order, pick up the most central value, that is your median. But this is just giving you, the central tendency. In quantitative data, you can also see how much it is spread out. That is dispersion. So you can say it is from 2 till 8, 2 till 10. That is your range, minimum and maximum. Or you can calculate deviations, mean deviation, standard deviation. These are the most commonly used methods. Now, how do we do it using different softwares? Mainly, the commonly used softwares are SPSS and Skater. There is also R environment, which is freely available. Now, so far as SPSS is concerned, I have just given you an example of how to do it in SPSS. Go to Analyze, go to Descriptive Statistics, and go to Descriptives. When you do that, you get something like this. Now you can check out whatever you want. Here you can have your mean, median, right? And it also allows you, once you've done that, this is the kind of output you get. So you have your mean, median, and then you also get an option of making charts. Why do you want to make charts? You want to make charts because you'll be able to visually see whether it is fitting something called a normal distribution or not. Now that is important because a lot of assumptions that we do make in using some tests are dependent on that normal curve, that bell-shaped curve. Now you can see this is not fitting a normal curve. This is going to one side. So this is where you have, skewness and kurtosis. Skewness and kurtosis. These are two additional elements that are there. Kurtosis. Kurtosis is just measuring the height of this peak. I go back. The height of this peak. This is leptokurtic. This is platykurtic. Platy means flat. So the height of your peak is being measured by kurtosis. Now skewness is actually measuring whether your data is this is the center, whether your data is this side of center or that side of center. If it is only one mode, unimodal, in that case it is easy. However, if it is multimodal, then it requires a more specialized technique which is beyond the scope of the present discussion. Now in continuous, you have this option, you can have your mean, your median, your mode, your standard deviations and your variance. Now when you're doing that, there is this option. You see, you've gone to analyze, you've gone to frequencies, you ask for mean, median, mode and whatever. Always go to this option which is histogram. What is this? What do you call this?
It's not visible, sir, actually.
Okay. That's a problem. Actually, I've just taken a print capture here. You see, when you go to this, it's a menu-driven program. That's a menu-driven program. So you go to analyze. From analyze, you go to frequencies. On frequencies, it will ask you for which statistics do you want. When you're doing the statistics, you go on to charts. On the charts, go on to histogram. And you can actually check whether it's fitting a normal curve or not. Now, why is this important? We were talking of using parametric or non-parametric test. In fact, sir is going to give an exposition on that. So, this is clearly not fitting a normal curve. Can you see that? So, it will be an error if we were to use the t-tests on this one. The parametric tests are not to be used here. A very common mistake people make is there are other specialized methods of evaluating this, which I've specifically not covered here. The goodness of fit tests. So this is, now it will be a slightly jerky, because after this we'll be talking of developing hypothesis, and we'll be talking of testing the hypothesis and tests of significance. That is going to be taken by sir. I'll jump on to the next portion. That is discussing about relationships between variables. Primary nuts and bolts course, we're looking at how to do it. Go to analyze, go to descriptive statistics, go to crosstabs, and you can pick up. Now, what exactly is your you can pick up correlations and goodness of fit tests here. So correlations, different type of correlations exist. You pick up your R value. 0 means no correlation. 1 or plus 1 or minus 1 is full correlation. So you can do it here, and after doing all this, you can go back and do some post hoc analysis of this. If you have continuous variables and you want to test the significance, the significant differences, you have different tests, you go back to, you can pick up the means, and you have these different tests, you have different non-parametric tests. Alright. This is how you're going to do it this is an independent samples t-test, so we'll be talking about it more. We go back to it, whenever you've done this, you go back and look at the significance levels. We'll be talking about one-way and two-way significance. So the significance is again important here. Different type of sampling methods exist. You have probability methods, you have non-probability methods. Whenever you have to analyze something, remember that if you give, basically whatever sample we have taken should represent the universe. That thing can happen only if you are randomizing and you're randomizing while taking your sampling. There are different methods of doing sampling. You can do clusters, you can do stratified, proportionate allocations. All these are possible. I'm not going to go into the details of the sampling methods and sampling techniques. All I'm going to go to is how do you determine that your sample size is alright? Or conversely, now you've just analyzed the data you had on your system and you want to see what is the power of this analysis. So it works both ways. So you can either test the power of your analysis or that is the power of your study, or you can go back and do sample size determinations. There are many ways of doing it. There are different softwares which are available. There are different web resources which are available. My recommendation, top two, PS and Stata. Easy to use. It's almost like a class 7 or class 8 student running through them. Easy to. This one is of course it's a copyrighted product and you need to buy a license for that. But for PS you don't need a license. You simply download it and you run it. When you do this, there are different methods that are there. So you can have your continuous variables. This is the survival. The Kaplan Meier analysis where we're using log rank, time to event values. basically only three types: binomial, normal, and time to event. So it will ask you what you want to do. You want to do sample size, or you want to take the power of your study, and then it will ask you a few questions about your variance, your power, and you will be able to get either the sample size or you'll be able to get the power of your study. These are the different web resources which are available. You can also use tables, and this is how you're going to do it in Stata. In Stata, what you do is you go to statistics, go to summary tables, go to the classical tests, and right at the bottom there is the sample size and power determination methods. Simpler technique, SAMC. You go there, right at the bottom there's this command. You can type this command there, and there's a syntax, and you manage to get your sample size or the power of your study. I don't think I'm really going to go deep into this. All I'm trying to say is, this is the power of your study. So when your sample size is small, the power of your study is smaller. Here it's becoming a little bigger, and here you have a bigger study. The most important thing to remember is that, underpowered studies are bad investments. They're not good investments for anyone. So if your sample size is not feasible, go back and take it with a pinch of salt if you want to base a decision on it. Or if you're doing a study, you're planning a study, you're still in a planning stage, go back and check out your effect sizes, your errors, and you also have the other options. You can use binary outcomes, you can use continuous primary outcomes, or use something which has a smaller variance. Smaller variance means smaller sample size. These are the different ways you can actually calculate your sample sizes. This is online analytical processing that we talked about, and we've already given you an example of data visualization. So I think besides this, there are other things that we do. We do data mining in our data warehouses. That is beyond the scope of the present discussion. Another important thing which is coming up very well is the heuristic working and the neural networks. So maybe next time we'll be talking of the neural networks, the generic algorithms, the fuzzy logic. But for the time being, I think I'm going to end my presentation and hand you over to Dr. Naik.